Hey everyone, welcome back to our channel. We're here sitting with Marcus from Stripe, who's a solutions architect with the past 10 years of payments experience. We're very excited to be sitting down with you today. You're going to be giving us a talk later around strong customer authentication and how to optimize for 3DS in the context of a payments integration. But for those who haven't really heard about SCA and 3DS, can you start off by telling us what this is and why developers should be interested in it?
Yeah, absolutely. Thanks, Alison. So strong customer authentication is a regulatory requirement under Payment Services Directive 2, which was the European Union's revised Payment Services Directive, which came out in 2019. It mandates additional identity verification for online transactions in Europe and the UK. In practice, for most online card payments, this means 3D Secure 2. Which is the EMVCo protocol that actually implements the strong customer authentication. Why should developers care? They should care because it's mandatory, first and foremost. But if you're processing card payments in the EEA or in the UK, the way you implement it has a direct impact on your conversion rate. So done poorly, it means friction, so checkout abandonment, people searching for their phone for one-time passcodes, these kind of things. But done well, and the vast majority of your transactions can actually authenticate completely silently without any interaction from the customer at all, while still giving you the liability-shift protection that 3D Secure provides. So the regulation is fixed and set the requirements, but the outcome of those requirements is not necessarily fixed.
Yeah, you make a great point around checkout abandonment and also optimizing when you think about maybe launching a business or expanding your business into Europe and having to really comply with regulation. What are some of the considerations that developers should be considering when they're looking to expand and incorporate strong customer authentication and wanting to balance the conversion versus compliance?
The most common mistake I see is that you treat 3D Secure as binary, that either you do strong customer authentication or you don't, but the framework is actually quite nuanced. So before asking how do I do 3D Secure, the first question should probably be, does this transaction even need 3D Secure? So a significant portion of payments are either out of scope. So this is the likes of your merchant-initiated transactions or your one-leg-out transactions, or transactions may be eligible for an exemption. So low-value exemptions is probably the most common example for transactions that are under 30 euros, don't actually need to go through strong customer authentication. But even for transactions that do require full SCA, the goal should be frictionless authentication, where the issuer's risk engine is satisfied based on device signals alone, with no actual intervention on the front end to challenge the customer. So the teams out there that are achieving, say, 70 to 80% frictionless authentication, they're not necessarily doing anything exotic. They're just routing correctly, and the protocol is doing the rest.
Yeah, so actually what's happening underneath all of the transactions is we're not just pumping every single transaction to require kind of two-factor authentication. It's actually leveraging analytics and data and signals to be able to then dictate which ones are more high risk versus low risk, and then being able to support frictionless checkout. And then you also mentioned the protocols underneath kind of 3DS and strong customer authentication. Can you talk us a bit more around the problems that the EMCV protocol is solving for and why it's helpful?
Yeah, absolutely. So at its core, 3D Secure 2 solves the problem of authenticating a cardholder who's not physically present at the point of sale, so e-commerce transactions. The way it does that is actually quite elegant once you understand it. So when your checkout page loads, signals are being collected from the browser, so things like device fingerprint, screen resolution, time zone, user agent, etc. And this is the part that perhaps surprises the most, or some developers the most, is that a hidden iframe is injected directly into the checkout front end, which points directly to the issuer, the customer's bank's access control server, so that the issuer can collect this data directly themselves. This is the data that the actual ACS trusts the most, and which they can use to come to a decision to whether to force a challenge or not. So if it's satisfied, you get a frictionless result and the liability shifts. But if it wants more confidence, it triggers a challenge. The protocol is genuinely sophisticated. The challenge flow is a fallback, though, not the design intent.
There sounds like there's a lot of different integration shapes when it comes to implementing SCA. So what are the kind of design and engineering decisions that developers should consider when they want to implement SCA? Do they go direct to implement their own version of the protocol, or should they maybe leverage an abstraction? What are the trade-offs?
Like building a raw EMVCo integration is one of those things that might look relatively simple on the surface until you get deeper into it. You're managing hidden iframe life cycles, the constructing authentication request payloads. There's around 150 data elements that actually feed into those too. And then you're parsing every single authentication response outcome and routing your transaction accordingly, or changing your flow accordingly, I should say. That's before you get to recurring transactions, whereby you need to record the scheme transaction ID and chain that to every subsequent transaction thereafter, keeping your recurring transactions compliant. It's thousands of lines of code to do all of that, and there can be PCI scope implications as well. And every time the EMVCo spec updates, which does happen from time to time, you're then absorbing the maintenance work for that. So Stripe Checkout, by comparison, abstracts every single one of these steps away from behind one API call for the user. And you redirect the customer. Stripe Checkout handles the rest, the iframe injection, the authentication request, the challenge UI should it be needed. For the vast majority of integrations, the right answer is to use Stripe Checkout and let your engineering team focus on your product.
Yeah, and I can definitely see how Stripe is able to allow you to integrate with just one set of APIs. And then under the hood, you're saying Stripe will then kind of build on top of the protocol across our 3DS engine. Another thing that we've recently launched is the standalone 3DS capabilities from Stripe. What should developers consider when to use maybe the standalone API versus Stripe Checkout?
Yeah, absolutely. So standalone 3DS is probably for architectures where the end-to-end checkout abstraction just doesn't fit, which can be certain use cases, which I'll talk about in a sec. Typically 3 patterns come up. So the first is delayed authorization, where you need to authenticate the cardholder while they're on session, but perhaps the actual authorization isn't processed until such a time later. That authentication value that's generated does have a lifespan, so you do not need to actually process it straight away, which solves for certain use cases. The second of which is the 3DS requester initiated framework, which is, or 3RI for short. This is where you have one authentication split amongst many sub-merchants. So think about like a marketplace type scenario. So online travel booking engine you might be logging on, making one authentication while the customer is on session, but then your authorization is going to get split between an airline, a car rental, travel insurance, etc. You don't want to have to re-authenticate the customer for every single one of those transactions. So 3RI allows for one authentication for the full amount, and each of those merchants then reference the same transaction ID up to the total amount that was authenticated. And then the final use case, which probably gets the most interest from some larger users, I suppose, is using Stripe purely as an authentication layer while routing the actual settlement through a different processor. So you get Stripe's device intelligence, you get frictionless optimization, and you don't actually have to change who you use to process the authorization subsequently. So in all 3 use cases anyway, the API returns your authentication value, your e-commerce indicator, and those can then be processed with any downstream processor as well.
You mentioned the EMVCo protocol. Can you tell us more about what the problems this protocol is solving?
Absolutely. So at its core, 3D Secure 2 solves the problem of authenticating a cardholder who's not physically present at the point of sale. So the way it does it is actually quite elegant once you understand it. So when your checkout page loads, signals are being collected from the browser. So things like device fingerprint, screen resolution, time zone, user agent, etc. Then, and this is the part that can surprise certain developers, a hidden iframe is actually injected into the front end, pointing directly to the issuing bank's own access control server, or ACS. The bank fingerprints the device itself directly through that iframe with no intermediary, and that direct signal is what the risk engine actually trusts most. Now separately, all of the data points that Stripe has captured also gets packaged up into an authentication request, and that gets sent to the issuer too, which also runs that through its machine learning. If it's satisfied, you can get a frictionless authentication and the liability shift for those fraudulent transaction or chargebacks. But if it wants more confidence, it can then force a challenge instead. The protocol is genuinely sophisticated. The challenge flow is the fallback, not the design intent.
How should developers be thinking strategically about enforcing 3DS across the transactions?
Yeah, so this is part of the conversation that tends to shift people's thinking. A lot of developers come to see SCA as a compliance cost, so forcing 3DS and introducing friction against their will, something that's imposed upon them perhaps, but it's also a commercial tool. So when 3DS completes successfully, whether it's frictionlessly or through a challenge, the liability for any subsequent fraudulent chargebacks actually shifts from the merchant to the consumer's issuing bank. And that's a significant protection, or it can be depending on your use case. So Stripe's radar rule engine lets our users force 3DS on specific transaction profiles. So if you imagine like unusual card velocity or card country and IP country mismatches, or else new customers who maybe have a high basket value, that kind of thing. The decision is essentially, I'm willing to accept a small amount of friction in return for liability protection should it turn out to be fraud. That can be quite compelling then in certain use cases where they are high-risk categories, or perhaps there's an elevated chargeback rates with a certain merchant in certain segments.
All right, well, thank you so much, Marcus, for breaking down these concepts. We'll be publishing his talk later on the YouTube channel, so be sure to come back and check it out.